Okay, so this was the partial key that was posted for day one. We're looking at polygons on the corner plane, triangles and quadrilaterals specifically. And then on day two, using properties of a polygon or special parallelograms to find missing points. So this was on Edmodo. Highlight. You're going to be using to prove something is congruent. You're going to use the distance formula or Pythagorean theorem, and you need to show opposite reciprocals to prove perpendicular. Now, I started a problem for you. You're going to first make a conjecture. Your conjecture could be incorrect. It's just an educated guess. So plot it, look at it, and come up with a name for the figure. Okay? So my conjecture was, I think it's scaling, and I think it's right, because they want you to determine if the triangle is right or not. So I'm going to look at this angle, C, and I got to prove that it is perpendicular if it is right. Okay? So to determine if it's scaling, we should have no sides congruent. Okay? And to determine if it's right, we should see opposite reciprocal slopes. I'm just going to go to the top real quick. So lengths, I could do distance formula. But if you just start with your slope, I'll show you some shortcuts real quick. So if you just look at lowercase m as your symbol for slope, the slope of AB, like look at your change in y over x, your vertical change over horizontal, delta y over delta x, your slope, rise over run. What is the rise over run for slope for side AB? Count it. Hopefully we see 7 over 2. Okay. Notice these two numbers here are right there in the distance formula. So if you use your slope, you can use it to find your distance, and I'll show you a shortcut for that as well. Okay, so this comes out to be square root of 53. The distance, the length of AB is the square root of 53. So I'm going to go back to my slopes, just looking at the slope of BC. Again, I'm going to do my rise over run, down 4, to the right 3. So I have a negative 4/3. Now, instead of doing distance formula, I can do Pythagorean theorem with these numbers. What they did here, what I was showing you here, is Pythagorean theorem is this: a squared plus b squared equals c squared. If I want to find just the c, then I just have to take the square root of both sides. So c is really everything underneath the radical, a squared plus b squared. Well, the beauty of this is if I take the square root of a negative number, it's always going to be positive. That's why I can say just 4 squared, because I could actually count a different way. So if I do it all at once, this comes out to be 25. The square root of 25 is 5. So I'm going to do the same thing for AC. Find your slope of AC. Count your delta y over delta x, vertical over horizontal, rise over run. Yeah, it's 3/5. So to find the length underneath the radical, I'm just going to put 3 squared plus 5 squared. That gets simplified to the square root of 34. So I literally have, if I look at each side, they're all different. So did I prove it's scaling? Yes. Okay, so my conjecture was right here. I'm correct on that part. Now, have I proved right triangle? Look at your slopes. Are any of the slopes, we have 7 over 2, negative 4/3, 3/5. Are any of them opposite reciprocal? No. So this part was wrong. My conjecture was wrong here. It's just scaling. Okay? So you conjecture that your original educated guess can be wrong. Okay? You're just using it to check and see if you're on the right track. So there was the first one. I think I gave you a partial key for the first 3. Alright, so after I graphed it and I looked at it, I'm thinking it's isosceles, and I want to check this angle and see if it's right, because I'm going to say it's possibly right. So I need to prove for isosceles 2 sides are congruent. And I need to prove we have perpendicular slopes. So remember I said start with your slope. What would be the slope of JK? I'm for real, I'm not joking. Huh? Yeah, it is 8/10. So to find the length of JK, yeah, the square root of 8 squared plus 10 squared, which comes out to be the square root of 164. All right, then we're going to do the slope of KL. Yes, I don't have to. I can use Pythagorean Theorem or distance formula, yes. You should still get to this answer. Yeah. As long as I see two of the same, I should be fine. Because I wrote on here, I say you can use the distance formula or Pythagorean Theorem for the slopes. Okay. One or the other. I think the slopes are faster. So, like if I do the slope of KL, we should see 9/1. So if I find that distance, or that length, that would be 9 squared plus 1 squared, square root of 82. And then I want to look at the slope of JL. Count your rise over run. That's down 1 to the right 9. So this is a negative 1/9. Negative 1 squared plus 9 squared. Well, that's also going to be 82. Yeah, and so now I can see right here we have opposite reciprocals. So we have proved perpendicular, and we have two lengths that are the same. So we proved isosceles, and I proved that it's right. For JL or for? You have to put 9/1 or you have to put 9. Because that reduces to just 9. No. Alright, so that's the same thing. On this last one, number 3, because you will be given equations or be given an equation, graph each line. So y equals 1/2 x squared plus 2. We should be starting at the y-intercept, which is 2. Use the slope 1/2 to graph additional points, up 1 to the right 2, or down 1 to the left 2. Just put a line through those points. Alright, then we're going to do x equals -6. That is a vertical line up and down. Okay, so it's undefined slope, so I just go to a -6 and draw the vertical line. Okay, and then y equals 4. We should see that's horizontal. So we go at the y-axis at 4. And then we're looking at what polygon is formed by the intersection of the 3 lines. What type of triangle? I'm going to see right triangle, because our horizontal and our vertical are always perpendicular to each other. So justify my answer, x equals a -6 is perpendicular to y equals 4. And if I have perpendicular lines, then I have a right angle. All right on that? Thursday. Coming up next week. Okay, so on this part, same process. Okay, we did triangles. Now you're going to look at quadrilaterals. So it's going to be the same process. Graph your points, connect them, make a conjecture about what you see on the graph. Then go back to your slopes. If we have parallel we have same slopes and we have parallel sides. Look for opposite reciprocal slopes because that means we have perpendicular. And then look at your lengths to see if we have any congruent sides. So on the partial key, I started the problem. I went ahead and graphed them. I looked at it. I said, I think this is a rhombus. That's my conjecture. What am I going to need to prove? I need to prove that opposite sides are parallel, so it's also a parallelogram. And we have 4 congruent sides. And none of them are right. Well, I can physically see none of them are right. Okay? So start with your slope of each side. The slope of AB, rise over run, is 1/4. The slope of BC, down 4 to the left 4, positive 4. Negative divided by negative is a positive. DA, 4, and then CD, 1/4. Look at my slopes. All right, so just looking at the slopes, if I look at opposite sides, these two slopes, are they parallel? Yes. Okay, so since we have same slope, therefore parallel. So I'm going to go ahead and add my arrows. They are showing opposite sides are parallel. Now I need to look at the length of each side. So if I'm looking at, let's say, CD, its length. Using my slope, I can just take the square root of 1 squared plus 4 squared. That gets simplified to the square root of 17, which we know has to be the same as who? AB. They have the same ratio, okay? All right, well, let's think about BC. What numbers would we be using for the ratio of BC? What would be the A and the B for A squared plus B squared? The slope is 4, so how would I write that as a ratio? No, not 1/4. 4/1. Well, so that means that's 4 squared plus 1 squared. We already know what that equals. What is it? Yeah, square root of 17. So what do we know about dA? It equals the same. So now I know that all these sides are congruent. So is this a rhombus? Yes. Here's what you have to do, okay? Because I know you're going to get a habit of maybe doing this. You make a conjecture, you have to have the work that proves your conjecture. Or you work it out and you change, after your results, you can change your conjecture. But you can't just say, it looks like a rhombus and you're done. You have to prove it. Okay? Have to prove it. So I gave you kind of the steps to start, what to look at for number 5. Okay? And you are going to be expected to finish the rest. Now, I want to talk about day 2. Day 2.